Every AI chat app is built by layering a few common components in increasingly sophisticated ways. We're going to walk through 6 levels of that architecture, from the simplest system prompt only app to a full agent workforce. By the end, you'll understand how every AI app you use is actually wired. Here is something familiar: an AI chatbot. You type into the chat box, you hit send, and reply comes back. But your message doesn't go straight to the model. It gets wrapped into a request, sent to a server, and then forwarded to the API that actually runs the model. Your message is in that request, obviously. But the server adds something you never see. It's called the system prompt. It's where the people who built the app tell the model how to behave for this conversation, the role to play, the rules to follow, the things to never do. Same model, different system prompt, completely different product. All right, so what about the next message you send? Would the model remember the previous message and continue the conversation? No, because the API itself is stateless. It doesn't remember anything between the first and the second request. The model has no memory of your previous conversation. It just sees a transcript and responds to it. Here's what's actually happening. Every time you send a new message, the server pulls out the full conversation so far, every previous user message, every previous assistant reply, and appends your new message at the end before sending it to the model. This chat history could either be stored and retrieved from memory or using a dedicated data store. So far, the model could do only one thing: respond with text. It couldn't look anything up. It couldn't take action. It couldn't reach outside its own training data. This was the case until the API evolved and added a new field to the request: tools. The server now declares, alongside the system prompt, a list of functions the model is allowed to call. Each one has a name, a description, and a schema for its arguments. Search a database, send an email, look up the weather, whatever the developer exposes. And the model gained a new kind of response. Instead of replying with text, it can reply with a tool use, a structured request that says, call this function with these arguments. The model doesn't run the tool. It can't. The server runs it, queries the actual database, hits the actual weather API, and sends the results back to the model as a new message. Then the model continues, maybe with another tool call. This loop can happen multiple times before the user ever sees the final answer. One message in from the user, one reply out to the user. But between them, the server and the model might pass requests back and forth 3, 5, 10 times. That's where the chatbot ends and agent begins. Now the model has the ability to take action. It could call tools. But the model still only knows what it learned during training. Ask it about your company's internal docs, your code base, this morning's news, and it has no idea. Another architectural evolution that fixed this problem involves an external knowledge store, a vector database, a document index, anything searchable. When the user sends a message, the server doesn't immediately call the model. First, it queries the knowledge base for content relevant to the question. The store returns the top few most relevant chunks, passages, paragraphs, snippets, whatever matches the query best. The server attaches those chunks to the user's message and only then sends the request to the model. The model now answers grounded in content it never saw during training. Your docs, your data, today's news. That's retrieval augmented generation. The model didn't memorize this data. The server handed it the relevant pages just in time. We know that within a chat session, the conversation feels continuous because the model is fed the entire conversation every turn. But what about across sessions? If you opened another chat window, how would the model know who it's talking to? This is where memories come into play. Underneath every chat session, the server quietly extracts facts from your conversations: your name, your preferences, what projects you mention, the way you like answers framed, and writes them to a separate memory store. When you open a new chat window, even before the first user message is handled, the server reads relevant memories from the store and injects them into the system prompt. Now, a relatively neutral message yields a personalized response that demonstrates the simple efficacy of memory. The model still has no memory between requests, but the server's memory now spans sessions. It hands the model what it needs to know about you, no matter how many chats ago it was learned. So far, we've been interacting with a single agent, one that could converse, take action, fetch knowledge, remember across sessions. But everything packed into one context window, one conversation history, one prompt, and one model holding the entire picture. Real-world tasks don't fit cleanly into one agent's head. Building a feature means researching, writing, reviewing, testing. Each is its own loop. Cram them all into one context window and the agent gets confused, slow, expensive. We can fix this by letting agents spawn other agents. Alongside the tools, the primary agent now has access to sub-agent types: a researcher, a coder, a critique. Each one specialized, each one with its own context. When the primary decides a subtask needs delegated work, it spawns a fresh sub-agent. Fresh system prompt, fresh tools, fresh messages. The sub-agent has no idea about the parent's full conversation. It only knows the specific task it was given. The sub-agent runs in its own agent loop. Maybe it uses tools, maybe it retrieves knowledge, maybe it even spawns its own sub-agents. When it finishes, it returns a result, usually a summary, a decision, an artifact. The primary receives the result like any other tool output and continues. Its context window stays focused. None of the sub-agent's detailed work polluted it. One user message into the chatbot, one reply back. But between them, an entire team. Specialists hiring specialists. The agent loop went from a single conversation to a delegation graph. This is where chatbots become workforces. We just walked from the simplest possible AI app to a full agent workforce. And the through line is context engineering, deciding what goes into the model's context window and when. Part 2 picks up where this leaves off, the ecosystem around the architecture. Skills are reusable instructions you can give any model. MCP is the protocol that lets models talk to your tools without you writing each integration by hand. Connectors are productized MCP, pre-built integrations for the apps you already use.